Okay, we can go ahead and get started. Hi, everybody. Good morning. Good afternoon, I guess, if you're dialing in from somewhere in Europe. Today, we're going to go through a quick orientation of how to use the Form 3, and we'll touch on Form 3L as well, the SLA resin printers from Formlabs. My name is Eliza. I'm hosting and moderating, and my colleague Sam is here to do the bulk of the presentation. If you want to move to the next slide. So webinars, typical Zoom format. If you want to use the chat during the presentation to, just chat with other attendees. But if you could use the Q&A tool to answer specific questions that you want to make sure get answered, then we won't lose them in the chat history. Next. So first, just to get a sense of where everybody is, we're going to do a quick poll of the audience, if we can launch that. Yeah, so the first question is, what's your role at your school? And the second one is, how comfortable would you say you are with using the Formlabs products there right now? And we'll give everybody a minute or so to answer that. While we're waiting for the last poll answers, people can put in the chat, where are you calling in from today? Sam and I are both, and our colleague Ekin, who's running everything behind the scenes, we're all in the Formlabs headquarters in Boston, Massachusetts, Somerville, technically. Be interested to know where everybody else is from. Chat is disabled. Fascinating. Okay, well, I'll look into that. Okay, do we want to share the results of the poll before we dive into the content? Great, so we've got a bunch of people who are professors, researchers, shop managers, some research assistants and grad students, and a couple undergrads as well. In terms of knowledge, it looks like about a third of people say they have a little bit of understanding, but not really comfortable how to use them independently, and then a good variation across the rest. 21% said no idea where to start. This is great. We will get you, the goal of the session today is to get everybody in a place where you feel comfortable using these products independently, or at the very least know what to do or where to go to ask for help. So in terms of what we'll actually get through today, if we want to go to the next slide, we'll start with, this is the welcome and introduction section. Sam will go into an overview of how resin 3D printers work in general, what to consider when you're choosing which material to print with. And then the bulk of the time will be spent setting up your first print, walking through what are all the steps. And then at the end, we'll go into what are some failure modes to look out for and troubleshooting tips in case you do run into trouble. And then time permitting, at the end, we'll do some live Q&A. With that, Sam, take it away.
All right, thank you so much, Eliza. A wonderful introduction. So yeah, as she said, the goal of this presentation is to have everyone feeling more comfortable around these machines, setting them up, and independently running your own prints. And for my lab managers out there, feeling confident with an entire fleet and using dashboard to set everything up, and just feeling confident in your PreForm orientations, things like that. And so first things first, we're going to talk a little safety. That's one of the most important things. When you're in the lab, pretty much 99 to 100% of the time, you should be using nitrile gloves. And The reason is that the resin doesn't get along with skin very well. So you want to avoid contact as much as possible. If you do get a little resin on your skin, it's nothing to panic about, but a little soap and water will take it right off. And you just never want to use alcohol to remove it from your skin. That's great for tables, surfaces, some printer parts, but for the most part, soap and water will get the resin right off, and you'll be good to go again. But changing gloves pretty frequently is a practice that we make good habit out of here at Formlabs, just because touching surfaces, doorknobs, things like that increases the chance that someone's going to get resin on their bare skin. And if you do get any resin on the orange shell cover there itself, there's a plastic polish that's really great. It's called Novus #1 plastic polish. And that'll keep your print lab looking, brand new and fresh all the time. IPA can fog up the plastic a little bit. So just keeping those things in mind, some good tips for safety. Now, the first thing that we want to understand with SLA printing is that it's not magic. It is a lot of science and math and technology. And so we're going to learn a little bit about how these printers work, because it helps to visualize what's happening in the machine to get successful prints and to know how to set them up right. And so we have two SLA printers for the most part, and those right now are the Form 3 and the Form 3L, and they both run on the same kind of system. So the way this works, and this is a great exploded diagram that you can kind of visualize things with, is that there's an LPU, we call it, an optical module, in the heart of the machine. And it scans left and right to draw the part in a single line. And so that centerpiece there is a laser, same laser that's on all SLA printers, and it scans across and only selectively fires at the bottom of the tank to cure the resin that it wants to cure to create an accurate representation of your 3D model. And so the 3L works much in the same way. It's just got some bigger parts, and there's actually two LPUs inside of the Form 3L, one in the front and one in the back, and they work together to scan the parts much in the same way as the 3L. But with the two, you're able to do things, but a little bit faster and a little bit larger. So 3D printing has come a long way in just the past 5 years alone, let alone the last 10 since we've gotten started. And so the technology that we're using now, we've invented, it's called LFS for short, stands for Low Force Stereolithography. And so one of the main problems with SLA is that there's a lot of force in between the bottom of the tank surface and the cured part. So when the laser fires the resin, it condenses those molecules together, they link together, and they also bond to the tank itself. And so how do you combat that? What we've come up with is using a flexible film so that everything is much more gentle. So if you have a flexible film, when the part gets bonded to the bottom of the tank, it peels up slowly and gently. And we actually have sensors that detect when a peel is successful, and then you can drop back in the tank and draw your next layer. And so what this has done is allowed us to use smaller touch points, get better surface quality around the edges and the curves of your part, and just better repeatable accuracy. So this is the guts of the LPU. This is the heart of the machine. It uses a parabolic mirror to make sure that the laser is perfectly perpendicular to the bottom of the tank. And what this does is allows you to get a more precise laser point. And this will allow you to draw, much more fine details, on organic models, sharper edges on square and rectangular models, and things like that. And it's all run by a galvanometer, which is a tiny electrical motor that can be run to very, very precise, just a small number of microns to be able to move. In the 3L, there's two LPUs. And so you have two galvanometers kind of working together in the same direction, just scanning across the Y-axis. and move the whole unit moves across the x-axis. And in combination, you get these really nice 2D layers that become a 3D part. So this is a great little diagram of the print process on the 3L. This is totally unique to Formlabs products. Other companies do it very differently, but that's kind of our advantage. So the build platform will lower into the tank, and then the LPU will slide on over and squish a perfect layer of resin in between the part and the bottom of the tank. And this is either 50 microns or 100 microns, depending on what you set. But some resins you can go as big as 200 microns. And this it'll draw the part in 2D, scanning across, spending a little extra time around the perimeters of the part and putting an infill. And then it'll gently lift up. The bottom tank will flex and it'll cause this gentle release that gives you nice repeatability layer by layer. So the first step is the squish. This, you might see it on your first couple layers, the build platform will plunge into the tank and everything gets, squished to the bottom. And that first layer is going to be crucial. So we cure it a little bit extra just to make sure that it sticks to the aluminum surface of the build platform. And then it'll lift up. The LPU will scan across, and it has these little roller holders on either side of the optical window, and that pulls the tank flat in place right below your part. And so that way you could draw a more accurate layer. There's going to be no lensing from the kind of flexible film, and you won't get any light diffraction. You get a very uniform layer of liquid resin, and that cures in place. Once your resin is cured, it's going to be stuck to the bottom of the film, but that's okay because the film is flexible. And so it'll be able to lift right off. And then it does that again, sometimes several thousand times to get some pretty complex geometries. So there are some specifications to this. As you can see, they're much finer than anything you'd get with FDM, but there still are limits to what the machine is capable of. So when you're designing your parts, some things to keep in mind: you want to make sure that raised features are, at least a 1/10 of a millimeter or 100 microns for optimal resolving, so that they come out and you can see them and feel them. And same thing with debossed features in engraving areas. You want them to be about 150 microns, otherwise they can get kind of filled in with that liquid resin. And any small posts or small connecting parts need to be at least 200 microns across. And this is because you can only build so much resin in a single direction before it becomes too much of a challenge. And the same is true of parallel walls or walls that stick straight up. They should be about 200 microns. And the printer can do overhangs nicely, depending, but you generally try to avoid them. But if you have a 5 millimeter overhang, especially if it's connected on the other side, that should be okay. But you may need to adjust if you start to get some flaws in your part. Gears should have a little bit of a tolerance, about 0.5 millimeter, and same thing with holes. You can get some really fine holes, but there are some tricks to that. Microfluidics is a field that our printers really thrive with. But like I said, there are some tricks. Sometimes you'd want to blast compressed air to make sure that all your solvent and alcohol is out of there before you cure it. And you can get some really interesting microfluidic models. So selecting a material is just as important as designing your material correctly. We have a huge library of resins in all sorts of colors and stiffnesses for a bunch of different applications. And we have materials that kind of mimic ABS and polypropylene and different types of plastic, although they are all a type of acrylate or acrylite. So we have our standard family of resins. We call them general purpose resins. These include black, white, clear, and gray. And these are great for our artists and anyone making just general purpose prints. If you plan on painting, modeling, or just kind of prototyping very simple low force parts, these are the best, most cost effective, most efficient resins to print in. And you should be able to print most geometries with these just fine. They're our most tested resins, and they're designed for really high accuracy and fine detail. And so it's hard to go wrong with these general family of resins. One resin I wanted to talk about is draft resin. I think this could be the most advantageous for schools. And the reason is that it can print up to 4 times faster. And so if fine accuracy and a smooth surface isn't your goal, and your goal is to get through the print queue or prototype something multiple times in a row and make small iterations to it to be able to design your part and keep working on it and move forward with things, especially when you have a lot of students trying to print in a small lab. Draft resin is one of the greatest for it. You just want to make sure to select 200 micron layers. And the resin both cures faster, as well as you can do larger layers. And so you can get these kind of same day iterations. You could print, 4 times the same part in a day. So usually they only take a couple hours, depending on how big they are, of course. But the quality of these parts is very much comparable to other parts. They're not quite as strong as some of our engineering resins. But if you don't need that strength and you just kind of are going to be putting on a shelf or painting it or just seeing if it fits in your hand ergonomically, draft resin is one of the best for that. And with engineering resins, there is a large family of engineering resins, and these are some of the most fun to experiment with. And for our engineers, you may need these for prototyping, especially if you're doing functional prototypes and need them to be a certain mechanical strength or tolerance. And we have technical data sheets on our website that you can find that show how strong, we have yield tolerances, Young's modulus. We've done extensive testing on all these resins. And so you can go on our website and find these technical data sheets and kind of drill down which material is going to be the closest to your end use material or stand up to the forces that you plan to test it with. Some of my favorites as far as engineering resins are the ones I've shown here. Flexible ADA, really interesting resin. It's got a kind of firmness to it, but it is still very flexible. And so for gaskets or any kind of ergonomic part, it gives just the right amount of give to it. It does take some special design considerations, considering it's a little bit flexible, which makes it a challenge to print. But when you do get great prints out of it, they work amazing. Durable is another close second favorite of mine. Durable is somewhat flexible, but tough to break. It's on the stiffer side, but it does have some bend to it. But it's a low friction resin. And so if you're designing parts that might need to slide against each other or rings, bearings, things like that, it's a low friction resin. Tough 2000 is sort of ABS-like. It is a very strong resin, and it can withstand a lot of impact force and a lot of bending before it snaps. And so for engineering, jigs and fixtures, it has like a low mechanical creep. And so it'll usually snap back into place and you're able to keep printing with it that way. And then there's high temp resin. This resin is quite impressive. It can handle really serious temperatures. One of our example parts uses kind of the nozzle of a butane torch, and it holds up to that heat just fine for small periods of time. And so for designing, parts that might need to have heat applied to them or high temperatures, high temp is a great resin to try out. And for our medical and dental labs, we do have a pretty huge array of medical and dental resins to take a look at. The Biomed family of resins is great for things that require skin contact or mucosal membrane contact, and you can prototype a lot of anatomical models, as well as like wearable medical electronics. These are great for that. Anything that you'd want to print that's touching your skin, you should consider biomed for. Another important thing to note here is that our resins are great for touching and handling, and that's just fine. But if you plan to wear them, all day, if you want to make jewelry or things that you would wear on your skin for a long period of time, there are a couple options. And one is to print in a biocompatible material like biomed, white, clear, black. There's a whole family of them. But there's also Tough 1500, which we've had approved for skin contact when it's processed correctly. And so that's one of those engineering resins I was just talking about. And so if you want to design jewelry or something that you would wear, a medical device, Tough 1500 is a great option for you. And then there's a whole family of dental resins, but that is for another slideshow. So now I wanted to walk you guys through the setting up of your very first print. And it's not as daunting as it seems, I promise. So it starts in your CAD software. You do just want to make sure that your mesh is complete. And that's just to say that it doesn't have any inverse faces. It's kind of some jargon, but when you are designing, it's something to think about. You can use a site like Mesh Mixer to make sure that your mesh is intact. But when you export it from CAD and you've made sure that it is a fully 3D printable object, you can export as an STL file or an OBJ file. And that'll give you a 3D file that is very simple. It's just the mesh of the part and with its dimensions. And so you'll go ahead and open that up in PreForm. You can download the latest version of PreForm from our site. And then when it loads in PreForm, you'll see it's either snapped to the bottom of the build platform or floating in space. And so the first thing to do is to figure out how this is going to be printed. And so we'll get into that a little bit, and I'll show you some tricks in PreForm. But for a lot of applications, you can just generate supports. Open up the supports tab on the right-hand panel of PreForm, generate supports. And most of the time, PreForm will come up with a pretty good configuration of how these parts should be printed and give you support structures underneath. And so that's the difference between FDM and SLA printing, is that for most parts with SLA, there will need to be a good number of supports because we are printing this with liquid plastic. It's a little bit less stable than a roll of filament. And so you do need a good amount of supports. And so after you've supported your model and you're ready to print it, you can upload it to your printer. And so to add a printer in PreForm, you can go to File, Devices. I'll show you that as well. And you should be able to see your printers if they're connected on the same Wi-Fi network. So that'll be kind of up to your lab techs. Get your IT team involved and make sure that all the printers are on one network and that they're visible in PreForm to all your students. And then they should upload very easily. And then they'll be in the print queue on the printer. Something to think about when you're setting up a print is the layer height and the resolution that you want. So with FDM printing, some of you may be familiar, the layer heights are anywhere from 0.2 millimeters to over a millimeter. So we're working on a much finer scale here. And so there's some differences in the way that you think about this. So with 25 microns or 50 microns, you'll almost never really notice the layer lines. They're not that prominent, especially on smooth features or features that print parallel to the build platform. You won't see very much layer stepping at all. It'll be mostly a smooth surface, except for, you can see on the top of these files, you can see a little bit of that layer stepping. Kind of looks like it's a digital, part, but for most applications, that's okay. And the difference is going to be magnitudes of time. And so the 100 micron print will print about 4 times as fast as the 25 micron print. And so for getting through the print queue, 100 microns is usually fine. I print in 100 microns almost all the time, and it's usually fine. If I was printing something that I was going to give to someone as a gift, or has to be a very fine model, very complex model, I would go down to 50, even 25 microns. But for most purposes, 100 microns, you won't really notice that layer stepping. So when you're getting started with the printer, it can be difficult to know where to start. And it's a messy process. And so, or can be, hopefully not. And so you want to make sure that you're gloved up, wearing gloves. And so I will take a look at the gloves here. My printer behind me here is not quite set up or plugged in, but I will show you real quick that inserting the tank can be a little bit of a tricky process. You do have to give it a little shove towards the back. And so it slides out forward and then up and out. And this is your tank here. And then you want to make sure that you're using the same tank as the cartridge that is installed. And they should all be labeled and stickered clearly. And then you give it a little push towards the back. And that should activate it on the screen here. Same thing with the cartridge. Just slide it in gently. And when it gets to the bottom, it'll update on the screen. And you'll be able to start your print. And so well, the last thing is the build platform. You do want to make sure your build platform is installed and it has that nice cam handle that you pull down to make sure that that's secured. And once you have your build platform, your tank, and your cartridge installed, you should be able to start a print. So we're going to talk a little bit about the accessories and consumables like cartridges, tanks, build platforms, and all the things that will need to be cycled through during the course of your printing. So like I said, the resin tank is all new as with this LFS technology. And so there's some special handling that you want to keep in mind, and I'll show you that. So with our resin tanks, and I have one right here, you do always want to hold the resin tank or store your resin tank in this box here. This orange cover is going to prevent that UV kind of area wavelength light from hitting your resin. And if that does happen for too long, the resin will start to cure in place as if a laser was hitting it. And so keeping your tank stored on a shelf, and they stack up really nicely, so it's really not much of a problem, but making sure that they get back into these reusable boxes here with the lid on top is going to prolong the life of your tank. And then so when you're holding a tank, you always want to hold it by the sides here. And so there's these nice little handles, and that's where you can kind of insert it into the printer. And then the bottom of the tank here is actually an optical surface. And so it's part of the printer's optical path, which needs to be kept as pristine as possible for the most accurate parts. Otherwise, you can get problems. And so you want to avoid touching the bottom of this tank. And if you do touch it, there are some things you can do. I'll show you how to clean it. And then there's this mixer as well. So this is the final piece. This comes in the side of the box when you open up a new tank. You'll just want to take it out of its plastic packaging and slide it into the left side, and it'll magnetically attach itself. And then you place it in your printer, and the printer will automatically fill it with resin. You can actually get ahead of it and fill it with resin ahead of time, but it's not necessary. The printer will do it on its own. It just takes a little bit more time. So another thing to mention is that you should always only use the tank tool that comes with the printer on the bottom of the tank. It's a soft plastic tank tool, and it won't scratch the film. We are worried about the film. It's a pretty tough film, and it shouldn't fail on you or cause spills. But of course, it is a film of plastic, so just making sure that you're careful when handling it. So I just went over a lot of this. Just being careful and holding by the sides, only using the tank tool. And this is the same process on the 3L. Except the mixer goes on the other side on the 3L. So when you're installing your mixer, it goes on the right side and it'll park in place. An easy way to remember is, does it snap magnetically to the side of the tank? If you have it on and it doesn't snap into place, it's on the wrong side. So just put it on the other side, and you should be good to print. So the tanks are detected, and we store data in the tank based off of what material is in there, how many layers have been printed, how old the tank is. And so that information helps us keep you printing safely and accurately, and prevents problems. And so on the Form 3, there's a little chip here, a little microchip, and that stores the data. It's a little storage chip, and it gets programmed by the printer, and that's what causes the detection. So if you're ever having issues, you can clean off the little microchip on the Form 3 tanks. Form 3L tanks actually have an RFID sticker, much like on your phone or your bus pass. It uses like a near field detection to give that data so that there's no mechanical connection. Makes it a little bit easier. And there's a sensor in the printer that will read and write to this little chip. Same thing with the resin cartridges. They do have this little chip installed. And you can also find on the bottom of the cartridges that there's a lot number. And this little sticker will tell you how old the resin is. And resin has a recommended lifetime of about 2 years. So if your resin is older than 2 years, it's time to swap it out. But other than that, you just want to make sure that this chip is clean if it's not detecting correctly, but it should be mostly self-explanatory. And other things that can happen is that this little nozzle here can end up a little bit stuck together. So you just want to give it a little push, a little squeeze, and that'll make sure that it's fully open and that your resin dispenses nice and quickly. So there's a little shampoo cap you may have noticed on the top of the cartridge. And it should be closed when the cartridge is out of the printer, because that'll create suction forces that prevent this valve from leaking, because the valve's not fully sealed. It is like a Nalgene water bottle valve. And then for printing, you want to pop it open, and that'll allow air to flow through, and thus the liquid will also flow through that little water bottle nozzle. For build platforms, these ones are as simple as it gets. On Form 3L, there is an RFID sticker, much like the one on the tank, and that just makes everything seamlessly kind of fit together, so you should have no issues with detection. But on Form 3, there's a little sort of optical sensor, like a pin, and when that gets put into place, that just makes it so the printer knows there's a build platform. I myself on Form 2 have forgotten to place a build platform and started a print, and that doesn't go very well, as you might imagine. So that just gives us an extra layer of safety to make sure that things are being printed correctly. There's a build platform installed, and the printer will not start a print unless there is one. All right, and so after you've gone through all those steps, printed your part, fast forward a few hours later, now you have a printed part. And so the question becomes what to do with it. So we send out a little toolkit with each of our printers that can be really helpful for removing parts. And you will need everything here. Some things that might not be included that you will want to get your hands on are PEC pads. These are photo emulsion cleaner pads. They're just a lid-free wipe that you can use to clean the optical window, to clean the bottom of the tank, and to clean any surfaces on the printer. A mallet can also be really helpful, especially for my 3L users. Parts can become very stuck, especially when using engineering resins like Rigid 10K. And so you do want to make sure that you have a little bit of extra force when you need it. So a mallet and a flat scraper in combination can be what's needed to get those parts off the build platform, because we want them to stick and to the build platform while it's printing. Like that's our first and foremost goal. So they can get pretty stuck on there, but I'm gonna show you how you get them off. And so the Form 3 and the Form 3L come with a build platform jig, some way to secure the build platform so that you are able to work on this in a safe way. And safety is going to be top of mind here, especially when students are in the lab. You want to make sure that everyone's watching their hands and watching their eyes, and following a good routine for removing parts. It should never be that hard to remove parts. So if you see someone struggling, just give them the hand, make sure that they're doing things safely. So the Form 3 build platform jig is like kind of a handheld one. I don't have one here on me, but that's okay. You want to hold it in place and you mount the build platform on the side, and it gives you the correct angle to be able to scrape down against the build platform. And then the Form 3 L1 is really handy. It's shown here on the slide. It mounts on the side of the table and has these holes, so you can place there's pegs on the top of the build platform for the 3L. And when you flip the build platform over, they align perfectly in this jig and keep the platform secure so that you have more leverage and it's secure so you can remove your parts. So it's shown here how the 3L build platform gets nested into that jig, and then you're able to remove these parts. And so I actually have a freshly printed, it looks like an orc from an unknown series, medieval. And so we have a couple prints here. This one is nicely printed on a raft. It looks like some sort of piece. This looks like a connector to maybe assemble a part. And so to remove your parts, I'll get nice and up close here. Especially on a raft, printing on a raft is the best way to get good part removal. And like I said, those first few layers are going to be really cured on there. And so how do you get underneath them? You can actually use these flush cutters here, and you come in parallel to the build platform, and you can get underneath the part. And so with these little ridges around the side of the raft, oh, and see, there it goes. I actually didn't need to. Sometimes you'll need to get underneath there with a spatula, and that'll help remove it. But we didn't need to because it popped right off. So that's perfect. And so now you have your part. And so your part is going to be on supports. I'm not going to remove these right now because it's a bit of a messy process. But you can see that with these fine touch points, they actually do pull off super easily. Especially when you go as small as 0.4 millimeters. You can even go a little bit smaller. 0.35 is probably one of my favorite sizes on the Form 3L because that LFS allows you to go pretty small. But just being careful with the weight of your part, considering the size of it, you may need to use larger or smaller touch points. We'll get into that. But you can also use your flush cutters here to remove your touch points. And you'll find underneath those support structures, you have a pretty smooth surface. It may require some sanding, depending on how perfect you want your surface to be. But for a lot of people, those little touch point marks can be scraped off with a fingernail or a razor X-Acto blade or your flush cutters, and you'll have a ready to go part just by removing it. So a lot of people are intimidated by these supports when they first get started printing, but they come right off and it does feel kind of magical. So this is this is a part that had already been washed and the IPA has been dried. This hasn't been cured yet, but for optimal mechanical performance, you will want to wash and cure your parts. Washing is not an optional step. You will always need to wash your parts because they will come out of the printer covered in liquid resin, and no one wants that. And so you'll have to put it into the form wash here. And there are times and settings for each part. It's actually just the amount of time that the part gets immersed in alcohol for. And you want to use 99, as close to 99% isopropyl alcohol as it gets. I will tell you right now, 71% alcohol does not work. 95% works really well, and 91% will pass. That it will get your parts clean enough, but you'll need to swap it out a little bit more often. And so it's better if you can get your hands on some 99 or 95% isopropyl alcohol. It's the best thing to wash your parts with. Some of our users use TPM, which is a slightly more complicated, but slightly more fire safe solvent. But you do have to use an extra water rinse if you're going to use TPM. So most people use IPA. It's just a little bit easier. Parts air dry. So when you put parts into the wash, you set it for the amount of time. 10 or 20 minutes is usually okay for a part like this, depending on how complex the supports are. You want to make sure to get all the resin out from these support structures. And so after the wash is done, the build platform or the wash will lift out and allow your parts to air dry. And so you can actually also just place your build platform here onto the rack of the form wash, and that'll place it in, dip it into the alcohol, and the alcohol will spin. There's an impeller at the bottom, so we don't need to run that right now. But it'll spin the alcohol, making sure to get in between all those crevices and everything, and then you'll have a clean part. The key is that you want to let your part dry fully before you put it in the cure, and so that can take about half hour to an hour for all the alcohol to dry off. And then once it's fully dry, you can go ahead and put it in the cure. And the cure also has times and temperatures that are recommended to achieve different results with different resins. Some of them it's pretty necessary for, like the rigid family, and some of them, like their general purpose resins, a little bit of an optional step. It'll make them feel more finished, more like a normal plastic part in your hand, because sometimes they can be a little bit tacky because they're still somewhat soft resin. So it'll just make them firmer, stiffer, more like a final part, and you can get ready to paint, sand, and finish your part. And now a quick note about cleaning is that those PEC pads that I mentioned, those are going to be essential for making sure that your printer is in good optical health. And so you can use them with a little bit of isopropyl alcohol to clean the bottom of the tank. But something to note is that you should never try to use isopropyl alcohol in the inside of the tank because that will wear away at the crucial film surface. There's actually two films here. One of them underneath, okay for alcohol. The one on top, not okay for alcohol. Plus it'll also get into your resin. It's best to just keep one resin type per tank and keep them kind of separated that way. That way you never need to worry about that. And you can also clean the optical window this way. And so to do that, there is a setting on the Form 3 where you can kind of move motors around for maintenance purposes. It's called motor moves. It's in the maintenance settings. And then you can pull the LPU, or we call it the X stage, the whole, kind of carriage that the LPU is in. You can move it out into the center of the printer and then just use a little bit of alcohol and one of those PEC pads or any lint-free wipe and give the thin optical window a cleaning. And you also want to make sure that there's no cured resin in those roller holders or any part of the top of that assembly. And a good thing to do is to check with your phone's flashlight. You can kind of hold it off to the side, and then I'll show you if there's any dust, fingerprints, smudging, resin, things that might be in the way of the laser beam. Anything in the way of the laser beam is going to prevent your parts from curing and cause kind of like slices through your part, pinholes, and other problems. And so optical health is of the utmost importance. Take a quick sip of water. We'll move on to dashboard. I'm gonna go ahead and take these off. So dashboard is an awesome tool. This is going to be super helpful for print labs to manage their print queue, manage their fleet of printers, take a look at their consumables, and have people be able to upload prints remotely from their classrooms and get them started by a lab technician or by themselves. But it's a great way to keep organized and keep your students and your printers organized. And so you can actually sign up to get notified. So when a print starts or finishes, you can take a look at it, see when it's done, see when you need to go to the lab to start your post-processing. You can also take a look at your resin levels and see when you need to make orders. You can order them straight through dashboard or find the link there. And you can manage all of your printers and see which ones need maintenance or need consumables. And so this is kind of a view of how dashboard works. And so if you have an array of printers on a wall, you can keep them kind of all set up and know when you can schedule prints so that you can get through a huge print queue. And I know that print queues for universities can get pretty long, and people can end up waiting days for a part, which is why I recommend draft resin. It's a great way to get through that queue and get everyone their parts in their hands. But this is another great tool in your tool belt to be able to manage that time-wise and make sure that the printers are running as often as possible, which is the best way to get everyone learning as fast as possible. And so dashboard will track all your prints. It will also keep logs for us to see so that when things go wrong, we can take a look at what the printer was thinking when it maybe made a mistake or what might have possibly gone wrong. And so all you have to do is sign up like you would any other site with your email, and you can add printers on the touchscreen. And you can opt in to email or text alerts, and then get your monthly printing reports sent to your inbox as well, so that you can see how much you printed that month, the utilization and efficiency of your printers and your fleet, and which ones might need a little maintenance. And so you can go to formlabs.com/dashboard, and that will pull up the dashboard registration. And then you do it through your printer's touchscreen. And that's the benefit of having a fully online Wi-Fi connected printer is that all that information is there for you to see whenever you need to see it. You don't always have to go running back to the lab to keep an eye on everything. All right. So this is one of my favorite sections of any given training is the PreForm. And it's a little bit more complicated than people make it out to be. It can be very simple. You can do a one-click print and get success, 90% of the time. But something that I like to tell users is that you're a little bit smarter than PreForm. It's a very simple algorithm, and it'll find things that you may not have found. But with a little intuition and carefulness, we can achieve better results kind of manually than you would in PreForm alone. And so a quick walkthrough through the application. It's a very simple application. If you've used other slicer softwares, you know how simple this one is. It's very self-explanatory. The size window here is one of the first windows, and the panels on the right. And you can scale things uniformly. I will say you are not able to scan things or scale things in the X or Y direction alone. It scales them uniformly, so you can make things smaller or bigger, and that goes down to 1/100th of or 1/100th of a percentage. And so you're able to scale things to fit tight tolerances. So if you're printing a batch of gears per se that need to be very, very tightly toleranced, there is a tolerance to the printer. They're not always down to the 1000th% perfect. And so sometimes you want to print, with a 0.5 or 0.1 tolerance to make it smaller or bigger. And with draft resin, you can print a batch of gears and find the one that works perfectly for your application. And then there's the orientation slide. This is kind of how things are set up in space. You can auto orient. And it will place the models close to the mixer side. And what that does is makes them print a little bit faster. I personally prefer to have my models be in the center of the build platform because that gives the most room for the tank film to flex for each layer. And so you get much gentler peels in the center. But you do get faster prints towards the mixer side, and most of the time you won't notice the difference in surface quality. You can use this orient to face tool. This is a great tool just to snap any flat sides down to the build platform and get the part kind of oriented that way. And then you can use the layout tool to kind of automatically lay out arrays. So if you're printing a large number of the same part, PreForm will give you suggestions on how to array them in a way that will print nicely. And so on the right side of PreForm, you will see a window that shows you the time estimate for your print. In that little clock wheel, you can actually click to get a more detailed estimate. It takes the printer a second of processing power to think about this and to think, how many layers, how many peels, how long is this going to take? And so you can get a much more accurate estimation by clicking that. It'll show you how many layers there are in your current setup and the volume of your print. And so this is how you can keep track of how much resin you're using. And the printability section is PreForm checking for possible problems. So it'll check for overhangs that are too large or start forming in space. It'll check for suction cups, which we'll get into in a little bit. And then it'll tell you if the part will print correctly or not, or it'll give its best guess. You can actually turn this off to optimize the performance depending on how fast your computer is. It can help to turn that off just while you're setting things up and then turn it on to give a double check before you print. And then this is the device details window here next to it. You can find this in PreForm if you go to File, Devices, and it will pull up a panel that will show you the state of your printer. And you can also, two important things here for my lab technicians, you can update the logs or you can download the logs through a manual copy, and then you can send those to us if you have a support case open with us. And you can also update your firmware through this printer and just make sure that all your printers are up to date. We did just release a new firmware last week. So if you haven't updated yet, for Form 3, it is 1.20.5. And for Form 3L, it is 1.11 point something. And so those are the latest versions. There's some really great fixes in there that improve printability. So if you haven't updated yet, now is the time. And so this is kind of the most complicated of the settings to take a look at. This is when you want to be the most thorough in setting up. Although you can do things very simply by pressing that big blue auto generate button, that'll give you a really nice orientation. But there are some considerations. So if you want to avoid putting support marks on the face of your orc here, or directly on the features that matter the most, you can do that by kind of orienting your part in 3D space and then generating them so that the supports will generate downwards and away from those key areas. And so you can also edit them manually. That's what that button edit all is. That'll allow you to get into those touch points and move these little gray orbs around so that you can edit them. The raft type, you pretty much always want to be using a full raft. And that was the part that I removed here, right here. So that's the full raft here. It makes it easier to remove from the build platform. And it makes it stick better to the build platform while printing. And so this part is printed with mini rafts, which you can see it doesn't have much of a raft. It has these little kind of mini rafts. And this works a lot of the time, but it can cause problems with larger prints. And so it's better to use a full raft. And density is the number of supports per area, per square inch. And touch point size is going to be how big those connectors are. And so these ones that flick off very easily are about 0.35. And a safer bet is about 0.5. That's the standard size. And you can move up or down depending on the weight or difficulty of your part. Internal supports will generate supports on the inside of your model. And so these would be considered internal supports here. These ones that connect from the part to itself. So you can turn that on or off. And then there are some more advanced settings here. I like to leave these alone most of the time, but if you ever need to, you can change things like slope multiplier will place more supports along a slope it'll place more supports or less. Turn that up or down. Height above raft is going to be the height at which the part starts building off of the raft. So you can make it a little bit lower, which makes the part kind of more secure, more stable, but also makes it more difficult to remove from those supports because it's so close to the raft. And then raft thickness, I always leave alone. 1.5 millimeters is perfect. And so one of the key things with SLA is printing flat surfaces at an angle. And so this is going to be crucial for success, is that you want parts to build gradually and not all at once. And so you can see that this part here was printed at an angle in both directions. It's a little bit tilted this way, and it's very much tilted at 45-degree angle this way. And so just like the iPhone case shown here, you always want to be printing at anywhere from a 10 to 20-degree angle. You can even go steeper than that. But the one thing that you want to always avoid is printing something parallel to the build platform, but on supports. And the reason is that it's sort of like those first few layers, it's sort of like trying to sculpt a wet piece of cardboard on fence posts. It's going to sink, it's going to warp in weird ways, and it's going to be a large footprint layer that tries to peel all at the same time. And it's a very thin piece of plastic. And so it might break, it'll cause problems. And so printing things gradually at nice shallow angles is the best way to get really good prints. And so the next thing to look out for is unsupported minima. PreForm will find these and highlight them in bright red rings. So if you see those, you're not ready to print yet. You need to go through and add a few more supports. And so it looks like those little terrain maps there highlighted. And that's going to give you a sense of where things start to form in space. So in general, things that are connected to the part won't need extra supports other than, what it needs to print normally. But if there's something starts forming, so like right here, the corner of his head here starts forming off of his shoulder. And so that would have to form in space. And so that's why it requires a little bit of support right there to continue that through.
Hey, Sam, I'm gonna give a couple of housekeeping notes if you want to take a second, get some more water. So sure. We are coming to the end of the hour here. We're running a little bit behind, and I want to make sure that for those who are able to stay on, we can run through the rest of the presentation. And then a couple other housekeeping notes include that the recording will be made available after the session. So even if you have to jump off now, you can come back and finish watching later. It takes maybe a day or so to process, but then we'll get that up over the weekend. Well, I mean, not over the weekend. We'll get that up probably early next week. And then, if you have to jump, thanks for sticking with us. And for those who are able to stay on, we will keep running until we have a couple more minutes left in the presentation, and then quite an active Q&A panel. So we can do some of that as well.
Cool. Thanks, Eliza. I will speed things up a little bit here. And so if people who are staying on, much appreciate your patience here. I hope that you're learning something, getting some good takeaways from this, but without further ado, moving on. I guess I was getting a little into detail there. And so this is an example here of cupping. So suction cupping is a very important SLA concept. So I will take some seconds for this. Suction cupping is when, just like when you have a suction cup and it's a cup shape and you put it on a flat surface, it'll stick, a suction cup to a window for a window hanger. And so that makes it really hard for parts to lift off the build platform every layer. Now PreForm does a pretty good job at detecting these. And if you ever have a cup shape, if it looks like you could pour water in there when you're setting up in PreForm and it would stay, that's a problem. Because those suction cups will make it really difficult to remove from the build platform. And what you'll see is layer lines and all sorts of problems. And so this is an example of PreForm not catching a suction cup. And so this looks like a pretty decent orientation for a new user. It forms, very gradually up to the top. but it does indeed cause a large suction cup. So this print would fail as it's set up. So it needs to be placed at an angle. And so I'll show you what a suction cup looks like in just a second here. This is the section we're going to talk about failures, types of failures, and errors that you might see. And so what to do if something goes wrong. First things first, never panic. These printers are self-explanatory and they work most of the time. And so if something's going wrong, there's usually an easy fix for it. So you can hop on the line with us or check out support.formlabs.com. There's articles for everything that I'm talking about right now and that go into detail and give you steps to be able to resolve it. But, you know, work with your lab techs or if your school works with a local vendor, you can work with them. They're also very helpful and trained on all this stuff. And so, yeah, make sure that your school, you follow your school's rules for escalating tech issues, you know, putting support tickets out there, however you guys handle it. And then we can take a look. And so types of failures, some failures are more simple to understand than others and easier to fix. This is one of the simplest most of the time. We call them explosions here in house because it does kind of look like, you know, part of the part exploded, but they're technically called undeveloped features. And so if you ever see these, it's a sign that there's more support needed most of the time. Sometimes it can be optical contamination. Sometimes something is stuck to the bottom of the tank or the optical window. And that can cause problems. But see in this file here and this photo, you can see that most of that wall formed, you know, the first couple of inches of that wall formed, and then it started failing. And so chances are it just needs a little bit of extra support structure there to help it form in place. And so that whenever you see a funnel shape or a V shape, that's because the resin is no longer sticking to the part itself, it's sticking to the bottom of the tank. And so that's blocking the laser's path and causing the failure to kind of compound out in both directions. And so it'll cause these funnel shapes. And so the first things first is to check the tank for debris and re-support your part. See, this part was printed parallel to the build platform here. And so that's going to cause problems as well as being somewhat under supported. And so you'll want to put this up at an angle, add more supports. This is a type of failure called delamination. And it's just because the layers didn't quite adhere perfectly to each other. This is usually caused by suction cups. So like I said, those high peel forces will cause tanks to, you know, over adhere to the part, and it'll cause the layers to not perfectly align with one another. And you'll get these kind of like weird layers that don't align. Two things can cause this. One is you have a big suction cup or a really large footprint layer. Two, your tank just might be worn out. And this happens, you know, the tank film gets a little bit old. It starts sticking to the parts too much, and it just needs to be swapped out. And then after every print failure, just about every print failure, as long as, you know, something didn't form quite right, there's a good chance that there's going to be what we call pancakes on the bottom of the tank. And that's what we call them internally. You can call them cured resin stuck to the bottom of the tank, whatever you want to refer to them. But I like to call them pancakes because they do kind of look like little pancakes at the bottom. But you do want to use the tank tool only, you know, never use a metal tool to remove any cured resin from the bottom of the tank. And you can use they're sort of like tweezers, go ahead and pull them out. But anytime you have a print that didn't form quite right, you want to kind of swipe around in there with the tank tool and just really hunt and fish for any cured resin. If you have a really particularly nasty failed print that had a ton of supports and it has like little pieces of resin, you can filter the resin. There's 190 microns is the size, but you can just use paint or oil filters to pour the resin through, and that'll just catch any of that cured debris and give you fresh resin to be able to print again. Now, there's some things that can go wrong. These are pretty rare circumstances, but I just want you guys to feel ready for them. Mixer check failure is going to be a type of error like that's mostly caused by those pancakes I was talking about. So if the mixer goes to swipe across, it's held on by magnets, it can get kind of dislodged by a piece of resin that's stuck in its path, gets dislodged. And so you just want to make sure that the tank is clean. If the tank's still clean, reach out to us. We'll show you how to run a little calibration routine that connects the magnets to the mixer a little bit better. And that usually clears it up. So nothing to worry about there. Sometimes you might see a resin level sensor error. This is usually because something with the tank. So the tank here has, it's a little, we call it the tank float. It's a little mechanism in there that will float up and down. And that's what tells the printer how much resin is in there. So if that tank float is stuck or lodged or not swaying freely, the printer will get really confused as to how much resin is in the tank. So you want to make sure that that's moving freely. There's also a calibration routine that you can run. So get in contact with us and we'll walk you through those steps as well. And the last thing is tensioner errors. The printer does have a mechanism that pulls this tank tension tight. So it pulls on this little gripper here and it pulls the film tight. And so if there's ever an error with that mechanism, it can be that the tank film is worn out and just needs to be replaced. So just try a different tank, try queuing up a print with a different tank. That solves it 80–90% of the time. Occasionally, we might ask you to reseat a cable, take the back shell of the printer off, plug and unplug something back in. Classic tech support advice. Do I need to plug this in or unplug it and plug it back in? And that does work a lot of the time. But get in contact with us and we will help you fix it. So nothing to worry about. And if there's anything weird software-wise, you start getting, glitches, bugs, you can always run a factory reset, just like a Game Boy or anything else, just kind of wipe the data and have a fresh copy of the firmware and making sure that your PreForm and your firmware are both up to date. That's going to give you the latest bug fixes, software improvements, print setting improvements, things like that. So that can help a lot of your problems. Make sure you're on the latest of everything. And if that doesn't work, you can run a factory reset. A lot of times the memory on the printer can get really full. It's about, I think it's like 8 gigs of memory. You'll have to correct me on that. Doesn't really matter. But so that can get full. So you want to either delete jobs from your cube or just run a factory reset and that'll give you like brand new software. And the last thing that you want to keep in mind for troubleshooting purposes is if you're ever having problems, you can always print a test file. And so this can be a test file of your choosing from, thingiverse.com or any other test file that you can come up with on your own. But we have one that we like to use and we might ask you to print it. And it has all these features that we're testing for, and we place it in each quadrant of the print bed. And that allows you to see what areas are struggling, what might be going on if you need to replace the tank, and gives us a baseline for optical health. So contact us if you're ever having issues and we'll send you this file. Or even if you're not having issues and you just want to have this file on hand, you can ask us for it. We'll send you this. And that just gives us a baseline so you can see how accurate, precise, and repeatable your prints are. Okay. And so key takeaways here, things to take back to the lab with you is just that workflow I was talking about. I hope I didn't make it seem too daunting. I hope you now feel a little bit more comfortable, queuing up a print. It's pretty simple. And so you just want to prepare your file. Make sure all your consumables are good, that you have a cartridge installed, your cartridge matches your tank, and you have your build platform installed. And then you click print, upload it from PreForm, set it up on the touchscreen and then sit back and watch. And however many hours later, you can remove your print, wash it in isopropyl alcohol, 95% or above, and then cure it if desired. So sort of an optional step for some resins, important for other resins, but throw it in the cure and that'll apply that extra UV light and some heat and give you a really solid finished part. Choosing materials. There's a whole range of materials that you can choose from depending on the needs that you need. So check on the website for those TDSs, we call them, technical data sheets. And that's going to give you a lot of jargon for our engineering students to be able to run through and say, is this resin going to be strong enough for our needs, or do we need a stronger one? And so for medical students, biocompatible resins, is this approved for 24 hours contact, longer? Can you put it in your mouth? All good questions. So that can all be solved by looking through the TDSs of all our materials. Appearance is another important thing. How fine detail do you need? What color resin do you want? Do you want it to be soft, squishy? And print speed. One of the most important factors, I think, draft resin is going to be the fastest. And some of them you can go down to 25 microns. And so that takes a few days to print, but you get some really incredible layers. And then just making sure to, a good printer maintenance prevents problems, just like with any machine. And so making sure that your optical surfaces are clean and that the printer is in good health. Every once in a while, you might need to clean and lubricate the lead screw on the machine. There's an article for that as well. Something I didn't mention, but something you can look into if that's your job, is to maintain these fleets of printers. You should look into the X-axis lead screw, and a quick Google will get you to that page as well. But just feeling ready for any problems that might come your way. It's not so scary. Most of the time these problems can be easily solved. So I hope that was helpful. Thanks so much for joining me. And I think we have some questions in the Q&A section. So let's open that up.
A bunch of questions.
Okay.
So I can read them out and then you can answer. So there's a couple that are product, quick yes, no product questions. So we'll start with some of those first. One is, should I close the cartridge in between prints if there's a long period of time in between prints? That's a little cap on the top.
Absolutely. Yeah, you nailed it. That's the perfect thing to do. Closing it is going to make it an airtight seal so that air, light can't get at the resin. But most importantly, it's going to prevent it from leaking out of the bottom. So if you leave it open, there's a chance that it'll drip slowly through that dispense cartridge, dispense nozzle. And so you do want to close it, yes.
Great, good to know. After how many prints do build platforms need extra maintenance, and what would that maintenance be?
Good question. Build platforms typically don't need a lot of maintenance. And so the scratches, you can see our build platforms are all scratched up, and that's normal. That's what you want to see. See tons of scratches on this thing. That's actually going to make parts adhere better. If parts are adhering a little too much because it's very scratched up after years of use, you can sand it down. I hear 400 grit is a good sandpaper. Just give it a kind of a light swipe in both directions, and that'll help the rafts cure better to the build platform and also be removed easily. But that's about it.
For PEC pads or PEC pads, are shop towels an alternative?
Good question. I can't say for sure. I've never tried using them. I imagine they're not completely lint-free. That's my concern. You can give it a test on a piece of glass, your laptop screen, whatever, some piece of glass. And if it leaves lint behind, it's probably not the best option for this because we are using a very fine laser point, and any small amount of dust will impact your prints. So I would say look for a lint-free wipe.
Great. I heard it's not recommended, but is it possible to switch resin types in a single tank?
Good question. The software will not allow you to do so. Has it been done? Perhaps. I can't officially recommend it. I know that we get pretty creative here in the office, and there are definitely workarounds for a lot of these things. We have some really creative users. No, I don't think that it's an easy thing to do. It would take some real creative problem solving. So not really.
Yeah, we don't recommend.
No, we don't recommend.
If not IPA, what kind of alcohol would you use to clean the internal part of a tank?
Good question. So you really shouldn't very often need to clean the inside of the tank. If you do, just a paper towel is usually what we would use, or a squeegee, and just try to squeegee out all of the resin if you are switching resin types in one tank. It's possible. There are some caveats to that. They need to be kind of the same family of resin or have the same recommended lifetime, because some resins are like chemically aggressive. So it's much easier with Form 3 to use just one tank, for each type of resin. So you should really never need to clean the inside of the tank, but if you do, something goes wrong, a squeegee, paper towels, no chemical solvents, no type of alcohol.
Good to know. How would you dispose of unused or expired liquid resin?
Good question. One of my favorite methods is by curing it. And so you can throw it away if it's cured is the rule. So you wouldn't want to put liquid resin in your disposal stream. That can cause problems, or down the drain. Obviously never do that. Incredibly bad for your water supply. So what I would do is kind of pour it into some paper towels, and then you can put those paper towels into the cure or out in sunlight, and they'll harden up and they'll turn to stiff plastic, and then you can throw them away that way. If you do want to dispose of liquid resin, you have like a whole cartridge that's gone expired, just follow local guidelines for chemical waste disposal. Hopefully your school has something like that set up.
Yeah, odds are your school will have some kind of waste disposal, like organization office. You can ask them for sure. It does. So the reason that we can't give a universal recommendation is not because we don't want to, it's because it's literally different in every country and every state. So, and then also different colleges will have, or universities will have different policies as well. So yeah, just check with your school, see if they have a policy. If they come back and ask, well, what's in the material, we have data sheets on our website that you can download on all the materials. And then presumably the people in waste services would know how to deal with that.
Good point.
Okay, moving into some slightly more complicated questions. Can we change the printer name?
No. I hope that you like your printer names. I love all the printer names. I love the adjective animal format. No, you cannot change them. You're kind of stuck with what you got. And that's okay. I learned to love your soft pony or fast horse or whatever you got. It would be fun if you could do that, but no, we just, for our purposes, keeping them straight, we cannot change them.
Yeah, traceability, etc.
Yeah.
Some more post-processing questions. If a part is still sticky in some areas, does that mean it wasn't washed properly?
Yep. Great question. Most of the time, yes. So there are two ways to fix this. One is wash it again, and two is cure it again. And so if there's excess resin, if it's sticky, it could be that there's resin that's not supposed to be there. That's kind of making it sticky, and so you can wash it again to remove that excess resin. If parts will come out of the wash a little bit tacky sometimes because they're not fully hardened resin. And so if your part looks accurate and you just washed it, you can put it in the cure to finish it off, and that will harden any resin and make it less sticky. But it could be that your isopropyl alcohol is getting a little bit too saturated with resin and needs to be switched.
Yeah, that would be my other recommendation, is that because it's a solvent, it does dissolve the resin, and so it will become saturated over time. And there's a tool that comes with FormWash to measure the saturation of resin, and so you can switch out fresh alcohol, will usually reduce stickiness. Mm-hmm. What would your recommendations be for parts that are bending during curing?
Oh, good question. That is kind of expected to happen with certain geometries. So if you have a thin part and it cures, what's happening during curing is that these molecules are making more connections and becoming harder. And so the part actually shrinks a little bit volumetrically. And so if parts are different widths in different areas, what you can do is cure it on supports. Sometimes you might even want to add more supports in PreForm, knowing that the part could warp during curing or bend, and just leave them on supports. And that'll kind of brace the part in place so that it cures more uniformly. Another thing to try would be kind of printing at different angles, different numbers of supports, Or you can actually make like an inverse jig to brace the part in place while you cure it. But that's a complicated solution.
I was muted. One person had asked a question that I did answer in text, but I wanted to ask as well, which is, do you have recommendations for polishing a clear part, whether with sandpaper, or I shared a guide on our website that also talks about spray coating and dipping.
Yeah, that's a really fun thing that I haven't had a chance to give a shot yet, but I'm really excited to do so. I know you can print optical lenses with clear, and a lot of like really clear parts that you can't do with other types of printers. My recommendation would be to, usually you can be pretty close right out of the printer, and then you can just sand down to really, really fine sandpaper grits, all the way up to 2,000, 3,000 grit sandpaper, and then using a polish, a type of polish to like actually just give it a once over with that, and you can usually get pretty close to optically clear that way. But really,
polishing compound is really important when you get up to those higher grits.
Thank you. Yeah, that's a good point.
Another question about clear resin: is it normal for it to turn yellowish after being cured?
Yes. So this is a known part of resin, kind of an unavoidable truth of resin printing, is that UV light cures the resin and continues curing it as it's been exposed. So there are two ways to combat this. One is to give the parts a coating of UV-proof clear coat, which can also make it a little bit shinier and more optically clear. And that will keep it from going yellow for a little bit longer. And yeah, I mean, that's the main way to combat it. Yeah.
Great. Okay, last question. If you have any other questions, write them in now. Otherwise, we're going to wrap up pretty soon. It's lunchtime where we are on the East Coast. So the last question that's written right now is about print time estimations. We want to have students reserve their time on our printers. Giving them a tool to estimate how much time to book would help us. And I know this is a pretty complicated question, so answer it as you will.
Let me take a look here. I don't believe there is. So the short answer is no. The long answer is you can probably come up with something yourself. Using like a test file, you could come up with like an average estimate for how long things should take, or just set things up in PreForm and use that kind of accurate time estimate feature where you press that button and it makes it more accurate, and that'll give you an idea, and you can come up with some averages of volume versus time. But really, the main thing that affects time is the number of layers vertically. And then also how big your footprint is. So it's really complicated to get an estimate of print times. But if you need to be in the ballpark, you can usually get within like an hour or two. But that would be a really helpful thing to have for your school. So something to look into. But no, we don't have anything like that.
You can also, this might be a case for using dashboard teams to help schedule prints.
Yeah. That's exactly right. Yeah, no, dashboard will give you that calendar for all your printers and show it in the 12 or 24 hour view, and you can schedule things that way. So dashboard's a great way to get ahead of that.
Okay, we have cleared the Q&A backlog.
Cool. Perfect.
All right. Thanks everybody for joining today, and for those who stuck with us all the way to the end. Sorry we went over. So as I mentioned before, a copy of this recording will be available either later this afternoon or early next week, and we'll send that out by email. In the meantime, thanks a ton. If you have any further questions, feel free to get in touch with our team, support@formlabs.com or support.formlabs.com. And we are excited to see what you will print.
Yeah, thanks so much for joining us. Until next time.
Bye.